this is your Chapter 1 test review. For questions 1 through 3, we're supposed to use the figure at the right. Number 1 says, what is another name for line L? Line L is right here. We need to pick 2 points off of this line. It could be any one. So we'll just say, it could be line AB, could be line BC, or it could be line AC. And it's just how you write it. Number 2 says, name the intersection of lines M and L. M and L are here. The intersection is point B. The answer for that one is B. Name 3 collinear points. Collinear means on the same line. So we can pick A, B, and C. We can also pick F, E, and G. So A, B, and C, or F, E, and G. 2 choices for that. Number 4, how many planes are shown in the figure below? Well, we've got the 2 ends. We've got the top and the bottom. And we've got the front and the back. So we've got 6 planes. Answer is 6. For number 5, it says EF is equal to 18.3, FG is equal to 21.2. Find EG. We're trying to find the whole distance. EF is 18.3, FG is 21.2. Find the whole distance, we add them together, so we got 21.2 plus 18.3 gives us 39.5 millimeters. And that's number 5. Number 6 says MN is 0.4, so 0.4 for MN. MO is 2.7. MO is the whole thing. 2.7, we're supposed to find NO. Well, if we have the whole thing and part of it, we need to subtract. So it's going to be 2.7 minus 0.4 is 2.3 inches this time. And that's your answer to number 6. Number 7 says find the value of the variable in JL if K is between J and L. Okay, so first we're going to draw a picture. 3 points in a line segment. K is between J and L, so K goes in the middle. J and L on the outside. JL is 6x minus 1. JL is the whole thing. 6x minus 1. KL is 3x minus 2. JK equals 4. Okay, if we want to solve for x, we need to set up an equation. We know that JK plus KL equals JL. And we just substitute JK is 4, KL is 3x minus 2, and JL is 6x minus 1. Combine like terms, we've got a 4 and a negative 2, so that's going to be positive 2 plus 3x plus 6x minus 1. Subtract 3x for both sides. Those cancel. On this side, we're left with 2 equals 3x minus 1. Add 1 to both sides. We've got 3 equals 3x, therefore we know that x equals 1. When we find x, we need to check to make sure that we've found everything. Variable and JL. JL is equal to 6x minus 1. We're going to substitute the 1 in here for the x, so 6 times 1 minus 1, which equals 6 minus 1, which is 5. So JL equals 5. That's number 7. right says use Pythagorean theorem and the graph to find the distance between R and S. So Pythagorean theorem, c squared equals a squared plus b squared. C is going to be the long side. Pythagorean theorem, we need a right triangle. So let's plot the points. R is at -3, 1, 2, 3, -2, 2. So it's R. And then S is at +4, 1, 2, 3, 4, +6, 1, 2, 3, 4, 5, 6. Okay. And we want to find that distance. Okay. In order to do that, use Pythagorean theorem, we need a right triangle. So we can go up and over or across and over. Do it this way. Over to right below the S. Stop and then go up. Now find A and B. This is C here. Find A and B. We're going to count the blocks. So 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, 8, 8. Doesn't matter which is A and B because we're adding them together. So we've got C squared equals, just take 7 squared plus 8 squared. So C squared equals 49 plus 4. C squared equals 113. We want C, not C squared, so we're going to take the square root of C squared. And we're going to have to do the same on the other side. When you take the square root of a square, they cancel out, so we've got C equals the square root of 113. And you cannot simplify that. Okay, number 9 says use a distance formula to find the distance between C and D. Well, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And we're going to plug these in. Now we need to identify these. We're going to call this one x1. It's the x coordinate of the first set. It's y1. This will be x2 and y1. What we have to do is plug those numbers in over here. So d equals the square root, parentheses, x2 is -2 minus a -1. And that quantity is squared plus y2 is 6, y1 is 2, so 6 minus 2, that is squared. So if we have -2 minus -1, it's -2 plus 1, which is -1 squared plus 4 squared. And that's going to equal the square root of 1 plus 16, which equals the square root of 17. There's nothing we can do with that, so D equals the square root of 17. That's number 9. Number 10 says find the coordinates of the midpoint of the segment that give us the endpoints. So we know the midpoint, we use the shortcut, stack them down, divide by 2. So we're going to stack them first. We're going to do 3, -2, and then 9, 8. We're going to add them. 3 plus 9 is 12. -2 plus 8 is 6. And we're going to divide this whole thing by 2. And that gives us 6, 3 for the midpoint. And finally, we're looking for the endpoint, given that R is the midpoint. So for endpoint, we're going to use MMS. Multiply the midpoint by 2, subtract the endpoint. R is the midpoint, so we're going to write that one down first. 1, 6. Multiply it by 2, so times 2 gives us 2, 12. Be careful not to carry over. We're just multiplying each of these numbers by 2. So we've got 2, 12. And now we're going to subtract the endpoint, which is -3, -5. So we're going to minus -3, -5. So 2 minus a negative 3 is 2 plus 3, which is 5. 12 minus a negative 5 is 12 plus 5, which is 17. So the end point is 5, 17. And that's number 11.